Hi everybody, Emily Kohmetscher here. I am going to present my screencast over week 13, problem 3, which is one of the voting problems. I chose this problem just because I really liked kind of the puzzle of it, and solving it was kind of fun at the end. And this is a concept that I don't usually teach in class. So I just kind of wanted to look further into solving this. So I'll go right to my slides here, which kind of explain how to work through problem 13. So uh, they start with four gentlemen that are a part of they're shareholders in a certain company. And kind of down here, I have put their individual shares. So Stark owns the most shares. Um, that's his last name. 32% is what he owns. And then it says Hammer, which is the guy that they're kind of trying to exclude, is the one that owns 17% or the least amount of shares. They don't tell us how much Banner and Rogers owns, but if all of them have to add up to be 100%, because there's only four shareholders in this company, then together those two would have to add up to be 51%. Now we know that Stark owns the most amount of shares at 32%, so that means that individually each one of these would have to own at most 31%. Maybe they only own 30% or 29%, but at most, the most that they can own is 31% because Stark owns 32. Now, if Hammer owns the least amount of shares or the least percentage of shares, at 17%, then that would mean that Banner and Rogers, one of them would have to own at least 18%. But if the other one can own at most 31% and they have to add together to be 51, then it actually has to be at least 20% and not at least 18%. So it can't be, one of these two can't be 18% or 19%, and has to at least be 20%. Okay, so then we kind of look at the coalitions of each of these four participants, or each of the four voters together. And we notice that there's 15 total possible coalitions, and doing that is a combination. So each one of them could be on their own. We could have a coalition of two people, and here there's 6 combinations of choosing 2 people out of 4. There's 4 combinations where we can choose 3 people, and then 1 combination where all 4 of them are, looking together in a coalition. Okay, so if we're trying to talk about Hammer, it says, why can Stark, Banner, and Rogers afford to ignore Hammer? So the coalitions that involve Hammer are the ones that are highlighted in yellow. There's 8 of them. And then we kind of dive further into what those yellow ones look like, or what will happen. So we notice in the first 4 of the 8, where the Hammer is by himself, P4 is his participant number 4. He only owns 17%, so that's going to be a losing coalition if he's looking by himself in the first place. P1 and P4, P1 owns 32%, Hammer owns 17%, but that's only 49%, so that's also a losing coalition. A winning coalition, I don't know if I didn't identify this on the last page, but assume that a motion carries as long as a coalition with at least 51% of the shares vote in favor. So 51% would have to be in favor. So these 2 coalitions would be less than 51%. Same thing with this one. So participant number 2, we don't know specifically how much he owns, but we know that it has to be less than 31%. And 31 and 17 added together makes 48. So I know that it has to be less than 48%, which is also a losing coalition. And then the same thing for player 3 and player 4, less than 31% and 17%, which is less than 48, or a losing one. So really, we only have to pay attention to these last 4 coalitions that are involving Hammer in each one of them. Okay, so what we're trying to do is we're trying to figure out whether Hammer is a critical player or not in each one of these coalitions, whether his vote would actually sway the vote one way or the other. So what we notice is that player 1, he's 32%, and player 2, we know that he's less than 31%, but we also know that he's greater than 20%. So if we have 32% and 20%, something bigger than 20%, we already know that that's going to be greater than 52%. So really this 17% is not going to do anything to sway the vote one way or the other because 52%, are already voting in one direction. So he is not considered a critical player because 52 is greater than 51. Same thing with this one, player 1, player 3, player 4. That player 3, we don't know what he is specifically, but we do know that he's greater than 20%. So same scenario. And then here, if we just have the 3 players 2, 3, and 4, we know that 2 and 3 added together have to be 51%, so that's already carrying the majority. And then 17% Hammer's vote is not critical in that case, so he's not a critical player. And then, if he's not a critical player in any of these 3, he's probably not going to be a critical player when we consider all 4 of the players together. And so I've kind of written that out here. Player 1 is 32%. The second and third player added together is 51%. So really the 17 is not doing anything. So the reason why the 3 others can afford to ignore Hammer's vote or his opinion is because he's a dummy player. He's not a critical player in any one of the coalitions that he's in, any one of the winning coalitions that he's involved in. And obviously not these, because those are all losing coalitions as well. So that's kind of how they can afford to ignore him. This is not something that I usually teach in class, but it's just kind of a fun exercise. I really think that if I tried to teach this to my high school students, they would, pick up on it pretty easily. Some of them would probably be able to follow the whole thing and be able to understand why this works. Some of my seniors right now, the senior class that I'm teaching there's 33 kids in there and 22 of them are girls. So they're very, very girl heavy, like 66% girls. And so last year when they were making all the decisions for prom, they, the girls would a lot of times, all of the girls would get together, form their opinion on, how they were going to vote for whatever t-shirt. And then the boys would, vote for another option. Well, if all of the girls decided to vote together, they were kind of figuring out that, the boys would end up being, or the boys' vote would all end up being dummy players because the girls are going to carry because they're 66% and they would just need a majority vote of 50%. So they were kind of already figuring out, how this works. And we're showing an interest in this voting. And so I think they would really enjoy looking at kind of this data and how those voting exercises work and the dummy players and that type of thing. So that is what I have for number 3 exercise on week 13.